Hello again. All right, today we're going to start doing proofs of trig identities. This is so exciting. Okay, guys, these can be extremely confusing, but I think if you stick to these couple of steps that I have outlined here for us, here we go, these helpful hints. I'm going to get something so you don't have to look at all that down there. But do write these guys down. This is super, super important when trying to solve these. So they're going to give you some sort of an equation, and we need to prove that this equation is true using the trig identities. And up in the very top of the lesson, you have those identities that you were told to write down, the reciprocal identities, the Pythagorean identities, and the quotient identities. Those are going to be used to prove these things are true. So write these down, make sure you pause the video and put these in your notes. When you get stuck, refer back to these and just start going down the line. It doesn't matter how you start, okay? I always start with the most complicated side, and we'll talk about that in a minute. You want to manipulate only one side of the equation to get the other side. You cannot start with the left, manipulate some things, rewrite some things, and also rewrite the right. It does not work that way. Start with one side to get to the other side. And it doesn't matter. You can start with the left or the right. It doesn't matter. If you ever see a square, you want to try to replace it with Pythagorean identity if possible. If you can add or subtract or use some distributive property factor or use conjugates, go ahead and do that to simplify. And this one is a really good one to start out with anytime you get stuck. I like this one the most, I think, is if you get stuck, try changing everything into a sines and cosines and then go from there. Okay, so I hope you have those down. It will be very beneficial for you to have. Okay, so this is the type of question we're going to have. So I have a cosine theta times cotan theta equals 1 over sine theta minus sine theta. I need to prove that this is equal to this. Okay, so I'm going to start, and if you look at your helpful hints, it says step one, or not step one. The first helpful hint that it had here is start with the most complicated side. So I think, looking at this, which one looks more scary? It's the right. There's no right or wrong answer. You guys could start with the left if you wanted to. Move with the left. If you can't figure it out, then you can try again with the right, okay? For this one, I feel like this plus or minus with a fraction in there, or I'm sorry, addition or subtraction with a fraction, looks kind of scary. So when we're adding and subtracting fractions, we need common denominators. So we're going to do the same thing here. So I'm going to put that over 1. I don't even look at this other side. I don't care about it right now. All I care about is simplifying this as much as possible, okay? So I'm going to take this guy and I'm going to get sine theta. I'm going to get a common denominator here. So I have 1 minus sine theta times sine theta, that's sine squared theta. Very, very important. Put the square with the sine, not the theta. This, when you have sine squared theta, that is sine theta times sine theta. If you had sine theta squared, that means you're taking sine of theta times theta degrees, which makes 0 sense. Okay, so we don't do this one. We always do this one. Super, super important. Put it in between the trig function and the theta. All right, so 1 and then minus sine theta, and I have my common denominator of sine theta. You do want to look at this guy to see where you need to get, but I found a common denominator over here. Remember, you only touch one side, so we don't even look at, don't find a common denominator with the left. We only are manipulating, which means changing it, one side of the equation, okay? And for this one, we chose the right because it looked the scariest. Okay, if you look at those helpful hints, it says to look for any squares to be replaced with the Pythagorean identities. So 1 minus sine squared theta, if you look up at the reciprocal identities on the very top of this lesson, you have sine theta plus cosine theta equals 1, which is a huge identity. It's where basically the whole unit circle comes from. And we will have a video, Khan Academy video, that shows you exactly where that comes from in a little bit more detail. But on these Pythagorean identities, it said that you can rewrite these to get separate squares first. So I could rewrite this if I wanted to get just cosine theta or cosine squared theta equals. I could rewrite this to get sine squared theta equals. So how can I manipulate this to get 1 minus sine squared theta? Well, sure I could. I could subtract sine squared theta from both sides. So cos squared theta is the same thing as 1 minus sine squared theta. So I can replace this top guy with this. Isn't that true? 1 minus sine squared theta, 1 minus sine squared theta is equal to cosine theta, is equal to cosine squared theta over sine. Okay, so I still have, technically, you're supposed to like rewrite this on every single line, which is just a little tedious. So a lot of times they'll just do equal signs, and then at the very last line, you can put that guy there, okay? But it's important to know that we still have this. We want to get this equation to be this equals this, okay? So I have a cos. I love that because I need a cos, but it's just a regular cosine. So could I maybe separate this to be cosine theta times cosine theta and then have a denominator of sine? Yep, those are equivalent, right? All right, but I just want a cos. I don't want a cosine over sine. So can't I rewrite this as cosine theta times cosine theta over sine theta? That's equivalent, right? This step, this guy is definitely equivalent to that guy. Which, look, I got cosine, cosine. That's exciting. Okay, now I need cotan. And, oh, well, look at that. Cosine theta over sine theta is cotan theta. So did I get what I wanted? I sure did. And then proofs are often ended with a little square. It's my favorite part because I just finished it. I like to say, wha-bam, when I finish it because that's exciting. Look at that, guys. Doesn't that look scary? And you are going to learn how to do it with no problems. All right, so let's try another one. Sine theta cotan theta equals cosecant theta. So start with the most complicated side, which definitely looks like this guy, right? And then you're like, okay, now what? All right, well, let's look back at our little helpful hints here. Cover up this bottom part. It's not to confuse you too much. Okay, complicated side, great. Manipulate only one side, sure. Squares, we don't have any. Adding, subtracting, well, there was nothing, right? It was just multiplication. If you get stuck, try changing everything to sines and cosines. I love that one. That one helps so many kids get out of a rough spot in trigonometry. Okay, so I think this is the most complicated side. So let's start with that because you can't really do anything with cosine. Let me rewrite cosine. Okay, there it is. Just kidding. You could do like 1 over secant or whatever, but that doesn't really help us. So let's rewrite this in terms of sines and cosines. So sine theta is sine theta. That equals cotan theta. If you go up to your reciprocal identities or your quotient identities would be even better because this is 1 over tan, and then we have to rewrite that. But if you see your quotient identities, cotan theta is equal to cos theta over sine theta. Okay, well, sine over sine, when you are multiplying something, can't you cross cancel if one's on top, one's on bottom, and you're multiplying? Yeah, I can. So I'm left with cos theta equals cos theta. Bam. How nice was that one? Not bad, right? Okay. Funny story, when I was teaching this one year, kids were taking their tests or whatever, and we'd always say the bam with a square. So during the test, people were just yelling bam out left and right. It was pretty funny. Okay, cosine theta secant theta equals 1. Start with the most complicated side, obviously, is this guy. All right, let's go ahead. I don't see any squares. I don't see anything I could simplify, really. Let me try getting that a little clearer for you guys. Oh, it's really thinking about that. Okay. Sorry, I thought that would be helpful. It didn't turn out to be very helpful. But I can rewrite secant in terms of cosine, can't I? Secant is the same thing as 1 over cos. Okay, so I could go top, top, bottom, bottom. So cosine theta times 1 is cosine theta. 1 times cosine theta is cosine theta. If you ever have the same thing on top of the same thing, just like 5 over 5, it's 1. Cosine theta over cosine theta is 1. 1 equals 1. Bam. All right, last one. Which side would you start with? I'd do that one because that one looks more gross. Let's do in terms of sines and cosines. I'm telling you, it's the best trick when solving these guys, I think. I mean, it will almost work all the time. Okay, so cosecant theta. So I'm going to go, I can rewrite that as 1 over sine theta. And then I'm going to make my division bar a little bit thicker just because I'm going to have a complex fraction here with a fraction over a fraction. So I just do that so I can visually see that that is the division bar. And then secant theta, well, that's 1 over cos theta. How do you divide fractions? You divide fractions by multiplying by the reciprocal, right? So we have to multiply by cos theta over 1. Those cancel out. What I do to one side, I got to do the other. Okay, so I'm going to get 1 times cos. That's cosine. Sine times 1 is sine. And then look at your quotient identities. What's cosine over sine? Cotan. Cotan. Bam.